Ladies and gentlemen, we'd like to invite you down to the Fabricator Stage. We have a presentation on quartzite and how to identify and deal with some of the issues relating and involving quartzite. We have a great presentation today. Mark Meriaux from the Natural Stone Institute and Scott Higginbotham from Treat. We'd like to introduce them and turn the time over and let's hear about some quartzite.
All right, you guys are all sitting down. Hopefully you don't mind if we have a seat as well. We've been here 3 days, just like you. Again, as Blake, thank you for the introduction. I'm Mark Meriaux with the Natural Stone Institute. We represent all companies involved in architectural uses of natural stone. Everything from quarriers, producers, distributors of slabs and landscape products, fabricators, installers, and restoration and maintenance, and all the machinery, chemical, supporting suppliers that support all of those companies above. I think we're up over 2,100, almost 2,200 member companies around the world now. Things we do is create and provide education for the industries. We have a standards manual we've published for over 50 years. We used to be the Marble Institute of America and the Building Stone Institute merged. We try to put together relevant information. Hopefully this session we're going to present here in the next 30 minutes will cover information that's helpful to you. And then we also try to promote the use of natural stone and advocacy for the use of natural stone in the industry worldwide. As Blake said, my name is Mark Meriaux. I run our Accreditation program, which is a credentialing program for fabricators and installers of natural stone. So if you want to be recognized as the best of the best, if you fabricate or install natural stone, come see me. We'll talk about accreditation or becoming a Natural Stone Institute member. I also manage our 2 safety committees, one for quarry safety and one for general industry safety. And then I also work as one of the members of our education team putting together presentations like this. Scott, tell me about yourself.
All right, thanks, Mark. My name is Scott Higginbotham. I'm the principal owner of Stone Treat. I was with Treat, an Australian company of impregnating sealers for years. Now I've kind of switched over. I still do that. I do stone forensics. I import cut to size limestone. I do domestic stone. So, we're going to talk about something today that's, you're here because you've either heard about a problem, had a problem. If you have it and you're using this material, you could have a problem, and go through everything of what it really is and maybe some tips and best practices for you.
So for the learning objective today, we'll start in, I'll do a brief intro into some basic geology and specifically on quartzite. We'll talk about some of the strengths of quartzite specifically as a building material and where it's best used as what applications. But more importantly, I think you guys are probably in the group that is experiencing some of the challenges of fabricating or quartzite installations and countertops. So we'll talk about what we're seeing, what Scott and I hear about from our industry members and friends, and some of the best practices to prevent, minimize, or fix staining issues that we're hearing about are so common. And then we'll look at a lot of pictures and case studies. We have more than we can get through. What is everyone's comfort level with quartzite as a countertop material? Everybody, zero comfort level over here.
So it sounds like something happened to you.
Something. Okay. So about quartzite, we have some fabricators out here though that I hear some fabricators around the country refuse to cut it because of issues they've had. Anybody in that group out there? We don't do any quartzite. We cut some quartzites, or we're very selective about what we cut. Yeah, maybe. And then other people have zero problems. We'll cut anything, we'll install it, whatever the customer wants. We don't have any issues. Zero issues, right? Good. Quartzite is a metamorphic rock. It's in the siliceous category of mineral-based stones. It started out as sand, beach sand, if you will, that becomes fused together as it's formed layer upon layer into sandstone, still highly porous sandstone. Then it undergoes a metamorphosis, and those grains within the sandstone get compressed and recrystallize and create what we know as quartzite. Many times there are other trace minerals evident in there that can alter and change the natural color of it. You can see beautiful blues and greens and veins of all different colors and varieties out there. One important thing is the amount of metamorphosis, the amount of transformation that occurs in that material can greatly affect how it performs, specifically with strength and absorption. I think I've got a couple slides here. So it starts out as beach sand. These slides were put together by our geologist friend, Karen Kirk, who has written a number of articles which you guys can access that are available to anyone through a separate website, our partner website, usenaturalstone.org. So these are taken from one of the articles she wrote, a deep dive into the properties of quartzite. So she shows how quartzite is formed from beach sand, the evolution, and then those grains fuse together. Some of it even gets to the point of melting and recrystallizing. And you can see some of the varieties of quartzite here.
Yeah, so when you have this sandstone, for those of you that do exterior work, you'll have a sandstone that becomes a quartzitic sandstone, then it becomes a true quartzite. And with this, the amount of heat and pressure creates this type of product, okay? Without the heat and pressure, you don't have the final solution. With these, there's different types. We try to put them in some type of category. It's hard because some of them start in one category to into the other. When you have porous sandstone like teak woods that are beautiful material, but they do have a lot of absorption, as they become more heat and pressure, the macabas like this, or even when they crystallize with more heat and pressure like the Taj Mahal, you have lesser problems in some cases and more problems with others. So we're not trying to pigeonhole one type of stone. All quartzites aren't bad, right? That's not what we tell people, but there are some challenges. As these sandstone grains melt and with heat and pressure, if they get enough, they can completely fuse together with no voids. And that's a good thing. It's when they do have some voids that are in there, then man steps in, and that's where we get to what we have here.
And so in the last session, any of you were here, sometimes you can see this with a very, very strong magnifying glass or a loupe or a microscope. You can see the actual grains on the surface of the material. You can see how tightly formed together they are. And you can also notice that when you're cutting. We'll see the pictures about that in the shop. Quartzite in general is made primarily of the mineral silica quartz. Silica, quartz, I'll use those interchangeably. Quartz is the mineral, silica is the mineral. But when it's formed into quartzite, it usually has a hardness. It's a very hard, very scratch-resistant mineral. On the Mohs scale, somewhere around a 7, 6.5, 7 usually. So it's usually harder. It's definitely harder than glass or a knife blade. Quartzite is usually harder and more abrasion-resistant than most granites.
Now, what this also means is it's harder on your equipment. If you're putting a slab of quartzite on one of your bridge saws versus putting marble or granite or something like that, you're going to notice it's going to be there quite a lot longer. You're going to be changing your blades, changing your pads. How many of you charge more money to do quartzite than other materials? That's smart.
Winner.
Right.
Good.
If you're spending more time having things dry out, more consumables that cost more money, you need to get that back, all right? Going into these pictures, when you see the different names of quartzites, and we know those are all regional or proprietary to certain distributors or we're talking about the intermediate quartzites, the ones that have that type of color, and they can go into be crystallization like Taj Mahal. You can add different minerals in it, like the blue Tahoe, and when you get into the fusion, you have so many of these different iron oxides, different minerals that make up all the beauty of this material. But those are also in some of the other materials, and that can cause problems later down the line.
And so in materials like fusion, you may have bands of other stone varieties, some marble, some calcitic minerals in there. You'll see, you can look at the material and see how all the movement and the waves as the different minerals and stones are smushed together and compacted and metamorphosized. But there may be in a material like fusion, there may be bands of quartzite. You may have solid bands of quartzite. Right next to it, you may have a solid band of marble or dolomitic marble. And so when you sell that material, when you understand what's going on and when you communicate that to a customer, it's important that you sell to set expectations to the stone's weaknesses and strengths. So the quartzite and quartzitic bands are going to be very scratch resistant, very acid resistant. Those marble bands within something like a fusion are going to be more like a marble. Should be sold and treated as a marble because they're going to be acid sensitive. They may scratch or etch in a kitchen application. But one of the reasons quartzite itself is desirable is because it is so hard and scratch resistant. I mentioned it's way up there, 6.5, 7 on that Mohs scale. Very, very difficult to scratch. There's no such thing as a what?
Soft quartzite. If you ever heard that term, lose it. All right? So, when we get into these things, when this piece of material was harvested, it's usually open pit quarries, it does not look this clean. All right? There's a lot of iron oxide, there's a lot of clay. There's procedures that are done, we're going to get into that, of what causes some of these issues that you may have, and you just need to be aware of them.
But the base minerals,
is a
silica that makes up the majority of quartzite, is extremely acid resistant. So that's a strong characteristic for selling it. It also has a beautiful cross bedding that creates those marble-like veins in there, and it's available in many lighter colors that have looks like the very popular white marbles. I mean, how many quartz towers you guys have in your showrooms that have how many varieties of white veined quartz? I lost count years ago. Every brand has about 15 varieties, I think.
And if you turn them upside down, you have new colorways. They just look the other way. So,
let's talk about resining for a minute. So you've got that sample up here.
Yeah.
So resining in general is done why?
So if we took this piece of material and we harvested it and we put it in a container and we shipped it to your address, just how it is raw, like a lot of material, when it showed up, it might not be in the condition that you would prefer. So some of the things that are done, these are resins, sometimes in the blocks, sometimes after they're gang sawed into slabs, they're resin. If you'll notice, I'm holding a bunch of pieces of fiberglass. I'm not repairing a boat. This came off the stone, all right? What this does is this is going to hold everything together. There's also resin in this that's been vacuum pumped in there. It's been acid washed because, like I said, there's going to be other minerals in here when it's harvested. So it's gone through with an acid wash. It may or may not have been neutralized. The spaces and voids where that iron oxide was taken out by the acid, it's got to be filled, so, all right? So once that resin's filled in there, the resin's backed in here, goes in the container, floats over to us, comes out. First thing you do to it is you put it in your saw, right? Stick it in a bunch of water, hit the on button. So things are going to react. It had a lot of movement, right? It got a gentry crane, loaded on this truck, off of that truck, loaded on that truck. So as it's doing all that stuff, it's getting moved around. This is an oven dryer, all right? So the resin slabs, you guys don't have one of these at home? No? Okay. So you just pop your slab in there and it heats them up, resins them out. So these type of machinery is done way before it shows up to your fabrication shop. So you want to be aware of what was the life of that slab before it got to you and the procedures that take place. And, again, it's got to be dry. You got to dry it out.
And the resining is typically done between the flattening process, the initial grinding process, but before the final polishing.
Right.
So usually the resin is applied. This is a great sample because you got a deep vein on there that's filled.
Yeah, well, I'll pass this around. It's got a filled vein in with resin.
But you mentioned that acid treatment. What's happening there?
So taking out those inorganic stains, you have to use an acid. That's what's used. Acid does not self-neutralize. So when that acid is put on here, acid will neutralize itself with an alkaline. If it doesn't, the next time it gets wet and water's added to it, which is on your saw, it's going to react again. And it could start to be reactive and dissolve those inorganic stains, right? And that can cause a problem.
What kind of challenges are you all seeing with quartzite? Anybody have any staining issues in the shop, installation? I'm seeing some no's. Some people with zero problems. Is that everybody? We've got some people out there. You're having some water absorption, some staining issues?
Edges. Yeah.
Edges.
So that's really what this
along the edges. Yeah, we're going to get into that.
Yeah.
So we talked about the benefits. It's extremely hard. It's extremely acid resistant. but it can be very fragile and brittle, and that's another reason why that mesh is usually
There to
added to the
protect
back.
it, to hold it together.
And that resin is put on the face to strengthen it, to make a better surface finish. But both of those treatments, the mesh on the back that's resin applied, and then the resin surface, even though most of it's ground away in that final polishing process, there's still a bit of resin on that surface layer that changes the absorptive properties. So you've basically got a sealed or a coated back, and then partially filled pores on the top. You've changed the absorptive properties of that natural material. But when you cut into it with a saw, what do you have on the edge? You got raw stone.
You expose it.
You've exposed raw stone that doesn't have that same treatment on it. Scott mentioned, are you charging more when you have to work with quartzite? We have some of the reasons on there. It's hard on your tooling. It's expensive to work with. You guys may have to buy a specialty blade or extra blades or stop in the cutting process to resharpen, open up the diamonds on your blade, slow down the fabrication. It may soak up moisture on the saw. It'll discolor or darken. We'll see some of that. You have to have time to let that dry. So it can slow production, slow to fabricate, may take a long time to dry out, take more time and labor in your shop. So you absolutely should be charging more to work with quartzites. If you're not, you're just shooting yourself in the foot. So you have to determine how long that's taking additionally in your processes and what that price should be. But you really should be. And when I give this talk to designers as well, I tell them to expect to pay more. If it's we understand it's a challenging material. They may not know that. They may think it cuts like every other quartz or natural stone.
You know, when you get pigeonholed by one of your, if those of you that do builder work, if you're working for the GC, or you can't get pigeonholed into per square foot, per square foot, and everything else. If you're taking more time to dry it out, post and pre-fabrication, if you're using more equipment and consumables, it's a higher cost. And there's no reason. And again, how many of you pick the material for your clients? How many of you pick the material? So you pick the material, so it's your fault, right? So the whole idea is we fabricators, you're going to fabricate it, but you didn't pick it, right? But it's your problem.
Ricky, what's
Period.
the problem when it gets to my house and my wife comes home and she goes, I don't like that spot over there. He picked it out for me.
Right.
I mean, what happens in that situation? So.
Always.
Some other ideas, just so you have a stronger understanding of what's going on. The materials that, for those of you who have seen some of that edge staining, the discoloration, some of the theories that are contributing to that include an acid bath treatment. So they're predominantly occurring on these white
Colors,
and light gray materials, macaubas and the like. Many of those coming from Brazil, not all of them I understand, but one of the things they're doing at the slab processing or quarrying level is putting these cut pieces into an acid bath so they eat away those unwanted.
They make it pretty.
Or
They take all the
undesirable.
unwanted natural colors out of it to get the white and the gray that you're looking for. That's the first step.
And we've got some slides that show what happens when that's not done correctly, when the acid's not neutralized or it wasn't in that acid bath long enough to get all of those undesirable minerals out of the material. And then we've already talked about the resining. We can talk about the categories, again, back to that Use Natural Stone article. It goes all the way from sandstone, the different levels, and we're talking about those ones on the bottom here, the intermediate quartzite or grainy quartzite, white macaubas. Many of them have Calicata in the name, Infinity White, Mont Blanc, all these different names. I can't possibly cover every single name.
Hundreds of them, yeah.
But then further along that evolution or development, the metamorphosis in the quartzite, you'll see the Taj Mahal, Madreperla, Sea Pearl. These varieties or names are less likely to have the staining or the absorption issues as those intermediate quartzites. What does the problem look like? It looks like these.
Right.
This is what we're talking about. If you haven't had this,
Yeah, I have a handout that I can get on our website, but when you first look at these issues, I've been working on this for probably 8 or 9 years. This is nothing new, okay? So there's stains from oil, from someone not cleaning up after themselves. This is not really what we're talking about. For years, everybody messed around with sealers thinking if they got the right sealer, they wouldn't have this problem anymore. And here's where the plot thickens, okay? If you first came apart this sink right here, you would think that the water's coming from doing dishes and they're just sloppy and everything else. The water that's in here was in there when you fabricated it. It's not coming from the sink. It was there when the slab was delivered. And water always wants to go to a drier area. It's extremely intelligent and extremely strong.
So it's
and
going to go from a more humid environment
to dry.
a less humid environment.
Hence your edges, hence your cuts, hence your fissures, hence your holes. So what's happened is that water that was fabricated in got stuck in the voids of that resin and that crystallized silica, and it took a while. Now, for the first couple of years, we would see a lot of these that were not showing up, never pre-installation. Unfortunately, it was after it was already installed when you started seeing these things. Then it was a couple of months, couple of weeks. I've actually had some that look perfectly fine in a house for a year and a half in a climate-controlled home. And then one day you flip the lights on, and it looks like somebody rubbed Ager all around your countertop. So again, this one here by the stove, if I came to this house, I'd be like, wow, you got to take it easy on the frying. You're getting too much oil over on the thing. But after closer observation, using a moisture meter, doing poultices, doing heat guns, torches, you realize, this isn't liquids coming from the top, it's liquids trying to get out. And they can't. Because what'd you do to the edges? You finished them. What about the bottom? What's going to come through a piece of fiberglass? Right? Anybody have a boat? Right? Water doesn't go through this. Okay? Now, oil stains from cooking, that's different. That means somebody spilled something and didn't clean it up. Completely different stain word.
But any cut edge, including the seams or the joints in the material,
Right.
any raw cut edge that you create, that's a new path for moisture to travel out of that stone. So it's going to go, like Scott mentioned, in that path of least resistance, and it's going to go towards that unprocessed, untreated edge as you cut into it, whether you're cutting into it to finish it or polish it. Other things we want to highlight is using the correct chemicals and adhesives. This one was spot set, obviously, by God knows what, if it was liquid nails.
Something they shouldn't use. I've seen a lot of these, but I've also, how many of you guys use suction cups to move your material around? Have you ever had suction cup stains? Okay.
So sometimes, even though you've got that resin layer at the top, you're putting an extreme suction in a concentrated area. You're it has no choice but to migrate towards that suction cup. And we're not going to comment on the vein match near that sink. If you guys get that under your skin, they only had a budget for 2 slabs, and they couldn't afford that
discount
third one
job
for this project. So some of the best practices you've heard include what, Scott?
So when we started looking at this, it's about protecting the material. So pre-sealing before fabrication is something that's out of orthodox. It's similar to tile setting. In tile setting, you set the material, you grout it, you seal it, you go to the next job. In fabrication, you cut it, you do the edges, you deliver it, you seal it, you leave. This is a different type of material, and it creates some issues, so there's different procedures. Pre-sealing it, right? So depending on your work orders and your schedule, there is time from selection to cutting, right? I hope no one here doesn't have that much business they can do it on the same day. But the whole idea is protecting it before it goes in the saw, then afterwards letting it dry out. Now, after you get it off the saw, don't immediately do the edges. Let those edges be raw, let them breathe out, okay? That's an open way. When you start putting an orbital on these edges, what happens when you heat up resin, right? What you're actually doing is closing the edge off. So we got a 6-sided piece, but it's only 5 sides because the bottom of it has fiberglass on it.
5.5, because you've got some resin on the top.
On the top, right?
Change that.
So the whole idea is let it dry out, okay? After it dries out, get some of this resin off here, right? You could take a cup wheel and I mean, if it were only this easy in real life, right? But take some of that edge so you have some raw exposed area. Do that around the edges, 4, 6, 8 inches. Do it around the sink cutouts. Do it around the punch holes. Let that piece of material breathe. Now, when that water goes to come out, I got a polished resin top. I have some sides that aren't finished, and I got a completely raw underside. The good news is that moisture is going to get out of there a lot faster. It can breathe.
So so that's one of the strategies. You're
Yeah.
providing another path for moisture to exit the stone.
Right.
By removing that mesh 4, 6, 8 inches back from the edge. If you're running CNCs, you're probably running a calibration wheel, so you're
Right.
getting 3 inches around any cut edge anyway, especially if you're doing a shape to it. But I would implore you to use one of there's special little stubby wheels I know to remove the mesh from the back. Go back another little bit back from any cut edge, overhangs, things where you're doing that finishing back around those sink edges or stove edges. Take that mesh backing off there 6 or 8 inches, just to give that moisture a path to escape. I mean, anybody who's experienced this probably has seen pieces in the shop look like the ones on the left here on the car.
Well, I mean, these are the lucky ones. I hate to say that, but this company, different ones, the problem came out before it was installed. It's still the same problem, but they can do something for this.
Still in the shop.
It's still in the shop. I've had fabricators replace kitchens 4 times with the same stuff. There's a word for that, okay? But the whole idea is that they didn't understand. I mean, there's 30 people here. We did the same conversation yesterday, right? I got back to my hotel room. I got pictures on my phone last night about this. So your phone's listening to you. I can tell you that, right?
And so that photo on the right, also, we talked about that acid bath. So those undesirable or unwanted minerals that might create off-putting or undesirable colors in that stone are eaten away through that acid process. They can leave voids in the material, and that's another path where moisture will migrate to. It may be along those veins where those off colors or minerals may have existed. I mentioned the bleeding. Use the correct color, correct type of adhesives. Every adhesive manufacturer has non-bleeding formulas. So I'd implore you to
get to know those 2 guys right there.
Yep, he's over there raising his hand. There's other guys here at the show, but all of them have non-bleeding formulas. Make sure you're using the right adhesive for the job. It may be a few cents more than the polyester you've used for the last 20 years to set every seam with. Don't keep doing that if it's going to bleed and cause you a permanent problem, cause you to have to tear out a project. So best practices we've learned from people we talked to.
So pre-sealing it, letting it dry out, letting the edges dry out, removing some of the mesh, sealing it again, time. Depending on where you're at, geography, and what the season is, you may have more sunlight or more heat. Use it to your advantage. Some people do heating dehumidifier dryer rooms to do this. But the whole idea is, in the beginning with your client, tell them it's going to do 2 things. It's going to cost them more money to fabricate, and it's going to take more time. All right? And even with all of this, I can't 100% confidentially say if you do all these things, you'll never have this problem. After 8 years and hundreds of pieces of quartzite test, I'm not 100% sure that every single one of these, it's not one issue. It's a multitude of things that's done to this material, and then a multitude of things, how the fabrication process goes, and then sometimes you just need a little bit of luck. But again, knowing
I've got on here best practices to fix issues. It's really to avoid issues. These are some of the best practices we've had. If you're going to take a picture of anything, it's probably this slide. The other thing Scott mentioned is, and we've had members do this, if you live in Florida where you are, you can just roll the tables out into the sun and let them solar heat, and they'll dry out.
Washington State, not so much. Or we actually see more problems in winter fabrication. It's weird. We see a spike in problems when fabrications are in the wintertime than the summertime, and it's because stuff's not drying out.
And so we've got a member company in the Midwest. One of the ideas they did, they took a 20-foot shipping container, a Connex container, put air conditioners and dehumidifiers on that unit, and made their own a low-temp oven, basically. They roll full carts like those pictures we just showed, with the pieces separated with wood strips, separated, let air flow through there. So they have fans inside that container in an extremely dry environment. It encourages that stone to dry out on its own very quickly. They do it overnight, and they're usually ready to go. They seal them and continue processing.
And if you don't own a moisture meter, buy one. There's a lot of moisture meters out there. They're not very expensive. You can pick up a General HH80 for $70, $80. Putting your hand on something is not a moisture meter, okay? I can tell you, because I do a lot of stone forensics around the world, I've actually put my moisture meter on dark pieces of stone that have a drier area than a lighter piece, which psychologically that's the opposite. We always look at darker pieces as being wetter than the other ones. Sometimes I've seen white bleach marks on this quartzite, right? It's not always the dark marks. There's just certain things. Know your chemicals. If you don't know your chemicals, ask somebody that does. All chemicals aren't the same. All stones aren't the same. All adhesives aren't the same. All pads aren't the same. Don't get caught up in the marketing part of it. Go to the science part. So.
And we've got some case study pictures here. We'll go through real quick, and we'll give you guys a chance to ask us some questions. But we normally do this with some of our other friends in the industry that do the restoration and try to fix these stains when they happen in the field. They can be improved, like you see here from left to right, the before and after. There's still a noticeable discoloration even after, even with the best methods, best efforts. But many, many, many times, it's just time. Just letting the stuff dry out on its own. Once it's in a conditioned air, low humidity environment, it's encouraged and it will naturally dry out over time in most cases. Now when you've done nothing to prepare for that in advance, you just rush it through the shop, don't allow it to dry. You've still got that trapped moisture in the stone. What's going to happen?
Yeah, so this picture came from Craig at GMR back there. And it's a great success story, but don't take this slide and think that this is always going to happen 30 days later. This is a success story. That's why it's in the PowerPoint presentation. But the yellow stains, we talked about the acid washes. What do you think these yellow things are? Iron oxide, rust, okay?
So it either wasn't acid bathed long enough to remove all the iron,
Or neutralized.
Or there was still iron deeper in the stone, but the acid wasn't fully neutralized. So that when it was wetted, or either with cleaning products or whatever, the acid was reactivated, reacted with that iron in the mineral, and then it causes additional yellow or rust staining. There's those white spots you were talking about.
The white spots, and sometimes you can get all three. And again, this could be from coming out from the stone. This is the cutting board things. You know, you take your sink cutouts, you do the same test, and you get different results. Sometimes they work their way out. You know, having a controlled piece at your shop. A lot of fabricators I know have started to catalog sink cutouts with lot numbers and everything else because they've had so much of this issue. They try to do a little bit of R&D themselves. A lot of times it comes up good. Know your suppliers. The streaks like this, you see, this is not a natural thing. When you see these lateral lines like this, we've all seen it when slabs are held together in a bundle outside and they get moisture. The sun comes out and you get a striping. This one here, one of my favorites. Those are all the fissures and everything in that material between the resin. It either wasn't resin correctly or through all that movement of transit, they opened up and you couldn't really see them. Well, you can see them now, right?
Anybody unload containers? You've opened those containers when they've come from overseas for a while. They're like
Phillips, flathead, crowbar, sawzall, dynamite.
But when you open the doors of that container, that moisture, that humidity hits you. It's been floating on the water for in a very humid environment on its way to make its way over here. Again, time can be your ally. It's not going to guarantee it, though. All these other steps we mentioned before are going to be your best practices. So first is understanding why and when the problem is likely to occur. So educating yourself, sitting through sessions like this. We've got recorded versions that our friends at Stone World have available through links at their website. I think we have, I know we have versions on our Natural Stone Institute online university, our Natural Stone University. We have versions of this session together there. And then understanding and identifying which varieties are more likely to present those problems with you, and then be prepared when those come through your shop. Have the best practices in place. Have a drying strategy in place, whether that's putting it out in the sun or setting up a low humidity environment. At install, use the correct adhesive. Use the best sealers that you can. Make sure it's sealed to rejection only after it's fully dry.
Right, because no matter what sealer you use, two objects can't share the same space. If there's moisture in there and you put any sealer in there, it's not going to be able to bond because there's already molecules of hydrogen and oxygen in there. So letting it dry out, getting a moisture meter, time. I know your customers don't want to hear it. It's a tight schedule, but in the long run, it's going to be in your favor the best you can. And if you have any questions, we can talk afterwards because we don't want to take up too much of your time. I have the white pages over at my booth, but thank you all.
Any questions about issues or things like this with quartzite or other stones? We'll do our best to answer them.
Hey, I was just wondering if you could expand on any adhesive you'd recommend for quartzite installations.
Bradley, you're up.
Adhesive.
This guy in the red shirt, you can learn more about adhesive than you'd ever want to know from him.
What type of
do you
adhesives are recommended for
quartzite?
quartzite?
In 30 seconds or less, Brad.
So I would recommend a polysporadic, which is not a normal MMA, okay? Just most of these...
Polyaspartic, is that what you, yeah, polyaspartic.
Yep. That will not bleed.
Perfect. And again, grab Bradley. He's great. I mean, wealth of knowledge, great friend. He knows his stuff.
Yeah, Integra IPS makes great stuff. Akimi's somewhere here, represented by other people.
Yeah.
They make good stuff. They have some non-bleeding options. 10X has a booth here.
Yep.
They have non-bleeding options. Talk to your favorite brand. Just ask about those non-bleeding adhesive options that they know. They're all aware of this too, like
Yeah.
Scott and I are, so they know what to recommend for you.
And correct me if I'm wrong too, but a lot of it, you could use a non-bleeding adhesive, but that moisture is going to draw to that seam, and so it may be the moisture that's the issue, not necessarily
If that's
the
still
adhesive.
the easiest path for water to escape, it's going to go to that cut edge, or unless you ground the mesh off the back and give it another exit path, another path out of there.
Perfect. Any other quick questions? Let's give Scott and Mark a round of applause.
Thanks. Thank you all.
Thank you. And Scott, are you here at the show? You have a booth where?
I'm at the show.
He's prepared this time. He has notes.
Where am I today? 7248, which is over.
So if you have any
behind
other
7 feet.
follow-up questions, want to talk to Scott more about sealers and what he recommends, talk to him there. I'll be here at the Natural Stone Institute booth right next door to this stage for the rest of today and tomorrow. Thank you all for attending.
Thanks.
Thank you again, Scott and Mark. The next one up is in 315. It's going to be porcelain practicalities. 315 back here at the Fabricator Stage for discussion on porcelain and porcelain practicalities. Thank you.